Hi everyone, thanks for joining our webinar. I will just wait for some time until we have a substantial amount of people that have been looped in and start right away. Thanks everyone for joining. Thanks Vinija for joining. She is so grateful to do this. Sorry, we are so grateful that you agreed to do this webinar, on such a short notice. So thanks a lot for that,
Absolutely.
and thank you so much. Just give me a second. And thanks everyone for joining. All right, so I think we can start the webinar. So, hi everyone, and welcome to our webinar. Vinisha, just feel free to share your screen, right? With the
Okay, sure.
yeah.
Sure. Let me do that.
So I see a comment about the chat being disabled. So we generally take up any questions or anything that you would like to say using the Zoom Q&A button, which is present at the bottom of your console. So feel free to use that, Michael. All right. So welcome to our webinar, and it's called How to Build an LLM Chatbots, a chatbot powered by AI agents. So my name is Yukti, and I will be your moderator for today. One of my main jobs here at SingleStore is to organize weekly AI webinars. We organize two or maybe three webinars per week and demonstrate different data and AI use cases and new tools and technologies. I also post about our upcoming webinars here and now. So I've not been able to do it for some time, but I keep on doing that. So if you're interested, feel free to connect with me to stay on top of the loop. And we would also like to hear your feedback or ideas on sessions that you would like to see in the future. So feel free to RSVP. I'll just talk about it right now. Can you go to the next slide?
Sure.
Thank you. So tomorrow we are presenting a webinar with Amazon. So building, Vinija can also talk about this one. So building an enterprise grade RAG with AWS agents and SingleStore. And on October 24th, that is also a partner webinar, building secure, scalable data access APIs with Hasura and SingleStore. So if any of these topics are interesting to you, feel free to RSVP right now. And I hope to see you all there. Coming back to today's topic, as I was stopping before, you're welcome to participate in the session throughout this entire discussion using the Zoom Q&A button. It is present at the bottom of your console. It's next to, I don't know, it's like right in the middle if you're able to see that. So uh, please feel free to use it. Just make sure that you have logged into Zoom with your name and email address because we will not be answering any anonymous questions. Moving on, I would like to announce today's raffle. So we are doing a lucky draw for anyone that tries out SingleStore. We would like you all to have a dynamic experience during this webinar and try out today's technology that we are showing off today. So in fact, that anyone who tries it today will be entered for a chance to win either branded new AirPods Pro or Meta's new Ray-Ban LLM smart glasses. It's absolutely your choice. So simply click the link or scan the QR code. It will directly take you to the trial landing pages, and our speakers and mostly our panel is going to give you like a hands-on guide, like how to get started, or if you already have an account with us, just log in. And if you don't, just rest assured, we also have a free tiered, and it also just takes about like 30 seconds to sign up. So we announce the raffle winner by the end of the day when we have a substantial amount of entries. So please feel free to try out. And if you have any questions, please feel free to drop them in. Moving on, I'm very excited to announce today's speaker and Akmal, who's there on the panel. Joining us today is Vinija, who is a database expert and an AI leader at Amazon, and Akmal, who is here to take care of all the questions that you might have regarding SingleStore or maybe any specifics that you might have. So feel free to, you know, ask anything. We have a panel of amazing experts. So take it away, Vinija. This is all from my side. Thanks everyone for joining.
Absolutely. And Akmal, if you wanted to do the intro on SingleStore's database, the intro slide.
Yes,
If
thanks very much, Venetia. We need to get you some updated slides. So, we'll share them with you, okay? So I think the theme and the color scheme we use now is very kind of simple. It's white and black, and I personally I like the old purple, but there we go. Okay, so I think you've kindly given me the opportunity just to one or two slides to talk about SingleStore. So SingleStore DB. Previously known, both the company and the product as MemSQL. very much focused around in-memory processing for OLTP. Subsequently added columnar support for operations, some min-max average count across large quantities of data to give you sort of analytics. And then it doesn't make sense to call yourself MemSQL anymore. I mean, that's the reason for the name change. So a single store implying the ability to store multiple types of data. And so there is this kind of concept of universal storage that can handle both OLTP and the OLAP, the online analytical processing. And the product itself, I mean, as a company and a product that's been around since 2011, so we've been around for quite some time. And it also has multi-model capabilities, okay? So yes, relational at its heart, but it supports geospatial, time series, JSON, key value even. There's a customer using it for key value that I'm aware of. I'm sure there are others, but at least one that kind of surprised me a little bit, but there we are. And vectors. So vector support has been in the product for quite some time. Very useful today, obviously, because of conversational AI, the ability to, if you've got images, videos, even sound, you want to do analysis of these multimodal data types, okay, as opposed to multimodal, which we talked about, then you have that ability, a representation of that a machine can understand in terms of numbers, okay, and that's the key thing there. Okay, great. Thank you, Venetia. And I think I may have one more slide. There we are. So this is a very nice kind of high-level overview. So essentially, in the middle there, you can see at its heart is the with the universal storage. On the left-hand side, we've got fast ingest from a variety of sources, whether that's Kafka or you're working with Spark, for example. Today, I'm struggling a little bit with revisiting some content I built a while back, a couple of years ago, and it's looking at Spark and scikit-learn and and then LLM. Did a comparison, and then I'm trying to update it. And so SingleStore can very happily work with these external tools and technologies, no problems at all. And we work on all three major cloud platforms, but I think obviously today, Venetia, you're going to be using AWS. We can run on-prem. There's a hybrid approach as well, which is kind of interesting. So part of your infrastructure can run within your environment, part of it can run in the cloud, and we have a Docker container as well. And so I mentioned the stored data types on the right-hand side, and then just across the top there, you can see a variety of uses, real-time decisions, dashboards, ad hoc queries, machine learning. One interesting thing about the dashboards that I would just say, just before I conclude, is that if you have some kind of favorite tool that you use, whether it's Tableau or something else, we provide JDBC and ODBC support. And my personal favorite is just Metabase. It's just a jar file. Just download it. All you need is Java. And then literally within about a minute, you can be connected, and then you can immediately start to create visualizations, pie charts, bar graphs, and so on. Very useful tool. And equally, we have now within the SingleStore cloud environment a portal that provides access to Jupyter notebooks. And that, again, so if you're familiar with Matplotlib, Plotly, Plotly Express, Seaborn, any of these tools and technologies, you can build visualizations very quickly. I'm actually today just been working with, as I said before, revisiting the content that I looked at a couple of years ago. So I'm creating heat maps and things with it all within this notebook environment. And with that, I will conclude now. I think I've spoken too much, eating to Venetia's time, and I'll hand over. And so I'll be on the Q&A, okay? So Yukti and I will be there. We'll do our very best to answer the questions as we can. Anything that we can't answer, we will follow up, as Yukti may have mentioned earlier. And so I will go dark now, and I'll see you in the chat. And over to you, Venetia. Thank you very much.
Awesome. Thank you so much, Akmal. And so thank you so much, everyone, for joining in today. Just kind of wanted to go over the agenda, the topics that we'll be sort of covering here today. So we're going to kind of look into the fundamentals of LLM chatbots and AI agents and how the LLM fits into the agentic architecture, how we actually integrate the LLMs with the chatbot platforms, optimizing any performance, enhancing user experience, exploring practical applications, and we'll have a quick short demo at the end of this where we're going to create a very simplistic agentic application. So how to build an LLM chatbot powered by AI agents. I wanted to kind of start off with a brief background here on AI agents. So agents are autonomous systems. You can think of them as sort of, if you have any human workflow or even any sort of a workflow where a decision needs to be made, which is not as strictly easy to just write rule-based rules for, where you need a full instruction end to end, that's where agents can really come in and help and sort of make those decisions smartly for you. And you can provide it with a lot of different tools. You can provide it with APIs, you can provide it with database, any external knowledge to help make those decisions. So they're autonomous systems designed to perform tasks by making decisions based on their environments and their inputs. They can sort of be described as the system that can use the LLM to reason through a problem and create a plan to solve and execute on that plan to solve that problem. So examples of AI agents can be customer service centers looking to just solve customer queries, where the agent will answer all of the questions the customer has back and forth. And you can kind of see in this diagram, taken from basically it's the chain of thought prompting technique, where you start off with the user asking a question here. Hey, agent, what's the maximum number of official matches that my team has played in this season? The agent will start off with its thought. It will start looking into figuring out how to reason through this question. Then it'll look into all of the actions it has. In this case, it's going to search the web. Once it searches the web, it's going to sort of pull out all of the relevant information from the web and then go back into its thought process until it's able to sort of get that clear, crisp response back to the user. And that's just how chain of thought prompting works here. Quickly wanted to sort of disambiguate AI agents versus virtual agents. So for virtual agents, you can kind of think of them as primarily designed to interact with users through that natural language, focusing on the user experience. They're very task specific. They handle tasks like reminders or managing emails. Not to say that AI agents can't handle those tasks, but it's particularly something that virtual assistants are very, very skilled at. They also have conversational abilities, and they're able to integrate with the ecosystem. So you can integrate with your smartphone, your home automation systems, any of your enterprise solutions, kind of offering that seamless experience. But virtual agents are really, truly focused on that sort of language interaction, that multi-turn conversation interaction. Not to say AI agents aren't, but their capabilities can be extended well beyond that, well beyond just a customer service or an interaction use case, where they can also sort of help with the user's billing inquiries, any sort of any end-to-end pipeline that you kind of need them to sort of step in and handle. They can do that because they're able to sort of make those decisions ad hoc. So coming back to agents now, agents are more so with the autonomy here. They're more so related to the autonomy, where AI agents sort of operate independently, making the decisions without human intervention, based on any programmed criteria or learned experience. So they're working autonomously based on what they believe is the best output to sort of help and give the user here. They have reactivity and proactivity. So AI agents can be both react to changes in the environment and take proactive changes to achieve any goals. And AI agents are very goal-oriented. So the design of an AI agent is primarily focused on achieving specific goals, which can range from solving complex problems to performing tasks like booking appointments. And they have adaptability here too. So many AI agents can have the capacity to sort of learn from the outcome and modify their actions accordingly, which is sort of a hallmark of AI systems within machine learning here. So an example here that I have is an agent asks, can you explain a difference between quantum and classic computing? The virtual assistant, the questions you can ask to a virtual assistant would be more so like, set a timer for 5 minutes, or, what's the weather today? To an agent, you can sort of ask, plan a week-long trip to Thailand, focusing on historical sites, cultural experiences within this budget. Whereas to a virtual assistant, you can kind of ask, find the nearest coffee shop, play some music. So the agent can sort of work end to end through all of your requirements and through all of your flow. And honestly, it can probably help you book and plan the entire vacation you're looking to take here, whereas the virtual assistant would be more better suited to just help you find sort of those one-off things that you're looking for within your trip. Can't really help you plan out your entire trip end to end for you. So now I wanted to kind of get into the meat of the agents here and start talking about their architecture. All of the different components that sort of build out the agentic architecture here. So you can start off with the agent itself. So we'll start off from the left here. So to the agent, they respond back to their environment. So say the agent was told from a user, look at the sky. Do you think it's going to rain tomorrow? If so, give the umbrella to me. In this case, the agent is actually a physical agent that can actually give the umbrella back to the user. So that's the environment. What the agent does is it's trying to reason through what the user's asked by using all of the tools that it has within its toolkit. So the first thing the agent will sort of do is it'll come in and look at the perception component here. And the perception is just looking at gathering all of the inputs and comparing and embedding them. So you can sort of see that. In this case, the inputs are multimodal. You have images, you could have sound, you could have text, you could have users, clicks, maps, whatever. And it's looking to embed them. Once it's embedded them, then it's looking to actually, start going to the brain of the entire agentic architecture. And the brain is called the orchestrator. The orchestrator, what its job is to do is to go through each of the components that the agent has and pick the correct one to solve the task that the user has at hand. So for this case, the next thing to do is to go to the action. And actually, first we can talk about the zoom in on the brain or the orchestrator here too. So the brain has storage, and the storage can be either short-term or long-term. So they're calling it memory and knowledge here. And basically what memory can help you do is it can, both memory and knowledge can actually help you in the decision-making, the planning, the reasoning, by using summarization, recalling what was done earlier for this decision, learning, looking to actually retrieve. So just generalizing and transferring that knowledge. And then once that knowledge has been gathered, then you can actually go in and take the correct action, whether the action involving text documents or any of the tools that you have, so calling, the APIs here, or any of the embodiments. And here it specifically means if you have a physical agent, so a robot here, would then the action would actually be physical, where it would be approaching the user back with the umbrella and giving that to them. So those are the sort of actions you can take here. This is just the high level overview of the agentic architecture. You can obviously have multiple other components here, multiple other modules, API calls, and we'll look into those more too within our demo as we go on. So now kind of wanted to talk to you about the simulated agent society, and this is from the paper here, The Rise and Potential of Large Language Models Based Agents, a survey. And I believe Yukti will have the slides over to you so you can also sort of go through this paper yourself. This survey does a great job at sort of doing a full survey, full overview of all of the different overviews of agentic architectures that exist, what can exist futuristically, and so on and so forth. So let's start going into the architecture of the simulated agent society. So this framework here, you can see you have the agent and then the environment here, right? And then you have the sort of agents working in a group together. So basically, it's divided into two main parts here, the agent and the environment. At the individual level here, you can see that the agent sort of looks to internalize a lot of its behaviors, like planning, like reasoning, like reflection. It also it can start to display intrinsic personality traits around cognition, emotion, or character. Now, these agents, when they form a group with other agents, they can sort of work in cooperation with each other, exhibiting a lot of the group behaviors and working collaboratively in society, much like humans do. So the environment here, whether it be the virtual environment or the physical environment with the robots, will contain both human actors and all the available resources we have as well as the agents. So now you can either have a single agent or the other agents, all will still be considered part of this environment. And the agents have the ability to sort of interact with their environment through perception here. And basically, the reason you kind of want them to be working in the group together is because then you can have very specific and individualized agents, some that are very good at a specific thing only, whereas the others may be good at something else. Maybe they have some overlap, but when you're looking for maybe a more complex task to be done here, say, building a house or something just a little bit more complex, what you can do is you can actually have the agents communicate with each other. So while they all have their own sort of planning, reasoning, reflection skills intrinsically, they can sort of converse with each other and get to a better result since they've sort of shared and combined all of their memory inputs together. Just zooming in a little bit even further down into the sort of the core components of the AI agents here. So we have the AI core, we have the agent core here. We have the memory module, the planning module, the tools, and at the very input, we have the user request. So the agent core at the center here, that is the central command and control center for the AI agents. Sometimes this is called the orchestrator. And basically what it does is it integrates the various functionalities to manage the tasks, to manage the direction flow, and ensure basically you have coherent operations across all of these different modules that you have. The agent core is the sort of decision-making agent here. It's the core of the agents and includes algorithms responsible for those decision-making. The algorithms can analyze data from memory, inputs from external sources, and make informed decisions to be able to best respond back to the user's request here. So basically what you'll have, ideally at the agent core is you can have an LLM here sitting here as the brain, and it's going to be sort of deciding which of the modules to sort of go into next. And that's basically, and the end goal of the entire agentic architecture here is to respond back to the user request with a very informed decision here. And responding back to the user request is more complex than just sort of saying, what is the weather today? the user's request may be, plan me an end-to-end trip to this city. In that case, what the LLM will have to do is look into the memory, figure out what sort of places the user really likes to go to, what weather the user prefers. Then once it has that information, it can look through its tools, maybe API calls, maybe whatever it has, and plan the entire trip out end to end, and then get back to the user with maybe tickets or maybe an itinerary, what have you there. Now we'll get into the memory module. So the memory module is what we saw here up top. The memory module sort of plays this critical role within the agentic framework here. And the memory module can essentially be thought of as a store of the agent's internal logs, as well as the interactions with the users. So you can, as we hit on this before, you can have sort of two types of memory modules here, short-term or long-term. Short-term can be thought of sort of like a ledger of actions and thoughts that agents goes through to attempt to answer single question from the user. So it can be thought of sort of like the train of thought, whereas long-term is a ledger of actions and thoughts that about events that happen between the user and agents, and it's a logbook containing a conversation history stretching across maybe weeks or months, whatever is relevant here. So, memory requires more than that semantic similarity-based retrieval here. So basically, the memory can be, the short-term memory you can sort of think of here as maybe even session-based, whereas long-term can be the history across weeks or months, and this can help in those key decisions like planning a vacation. The long-term memory will come in here to help understand what types of vacation this user really likes. And then or like what types of vacation this user really likes during this time of the month, to then help sort of get that information and sort of start planning trips around that information that we have from the user, that the short-term memory wouldn't sort of give us those signals here for that. The next is the tools module here. So the agents can use a variety of different tools. You can have executable workflows as one of your tools. And an executable workflow are sort of a scripted actions or processes that you kind of define at a very high level that the agent will take to perform a specific task. So for a workflow, you can think of something like maybe sending out an email, executing a transaction, retrieving data with some forms of authentication needed. So basically, it's going to be different sets of components that are all sort of combined together to make one entire flow happen. And these will have sort of hooks in it as well for any automation needed, kind of allowing the agents to trigger them when certain conditions are met. And these will be run without any manual intervention. So if the user comes in and they hit the criteria for any of these executable workflows, the agent will be able to sort of run these without any human intervention. So say they're coming in and saying they need a specific task, or they need to sort of get a hold of someone, then if your workflow is defined as sending emails, what the agent will be able to do is recognize that the user is trying to correspond with someone. It'll find that email workflow within its toolkit and be able to execute and send that email out for the user. The next tool here can be APIs, and your APIs can be both internal and external. And what I mean by external is you can have a weather API that you call. You can have sort of the travel, the airline APIs that you're calling externally to get information from them. Whereas internal APIs within your own sort of system, you can have any checks. Maybe you have some information about the user, maybe you have your own system that your user needs to sort of interact with. So that's kind of an internal API that you can sort of call within your workflows. And just to mention here, the executable workflows and APIs can sort of work together as well, depending on what you're trying to accomplish with that workflow. And you can also have any middleware here too that can sort of help with the interactions, any security, any error handling, any formatting issues that can sort of happen, because at the end of the day, the workflow, the API calls, this is all code. So you may need to sort of manipulate the data that the agent is getting from the input. And in that case, you can sort of have a lot of these middlewares to sort of help you out with any of these tasks here. Also want to go over the multi-agent system that we sort of covered a little bit earlier. So in the multi-agent system, there, and this is going back to the survey that I had mentioned earlier, they came up with these sort of two different groups of ways that the agents can sort of work together. You can either have cooperative engagement or sort of adversarial interactions that can actually help bolster the agent's understanding here. So cooperative engagement can be both subdivided even further into disordered or ordered. So you have the group of agents living together in an environment, and they're looking to communicate with each other to get to the end solution. A disordered case here would be sort of everyone talking all at once at the same time, and you're sort of trying to get to the answer. It may be easier to implement. It may be harder to sort of get to the end answer as quickly. Whereas the ordered system here would have then designated roles assigned to each agent, like how we sort of work in society here. So you'll have a manager, a designer, an engineer, a tester, and the manager can kick off things and then ask individual agents here and then sort of go on from there. So in this case, the manager starts asking the theme of our product, the designer sort of pitches in and says the architecture of the product, the engineer shares the code, the tester can then run the code, and you have your entire end-to-end flow there. The adversarial interaction here is more, it involves dynamic strategy adjustment. So it can actually incorporate game theory concepts here. Sort of what it's looking to do is it's looking to encourage debate and decision making. So the example here, the designer says, I think the user needs a simplified interface. Engineer says that's a good idea, but technical limitations might affect performance. The designer says, true, while simplification does enhance user experience. The engineer says, yeah, but performance issues also impact overall satisfaction. I'll try my best to balance both aspects. So they're just basically going back and forth, having this key discussion and debate to be able to get to a better end product here for the user, kind of doing a lot of the analytical thinking and reasoning as humans would do in the same environmental setting there. Now, also wanted to touch on multimodal agents as well here. So especially if they're looking to live within our environment contains more than one modality. You'll have, images, text, music, videos, and the agents can ideally be asked to take sort of all of these different modalities within their input. And these are sort of the different ways that they can sort of incorporate a lot of these different modalities within their environment. Keep in mind, they still have within their core, the agents still have the sort of action, planning, perception modules and planner here to be able to sort of execute on all of their decisions here. So the perception here, the large multimodal agents are basically looking to analyze the data from the different sources that they're going to have, and they're going to identify the objects in images or understand any of the spoken languages that is shared as the input. The planning module, what it's looking to do is they're looking to reason, plan, formulate a strategy to execute on. And then what the action is actually going to do is take that plan and look to actually execute on that strategy, leveraging all of the different tools that it's looking to have there. And the memory module is optional. It's not always needed in this architecture that the paper is proposing. In this case, they have the long memory here. And basically what you can store here is you can store a lot of the decisions, any of the key information, and then the agent can look to recall this information to help the decision-making and help personalize that decision-making experience by remembering the user's preferences for any future interactions. You can have a lot of automation happening here. You know, with these use cases, you can kind of think of maybe even game development happening with all of the multimodality needs of that use case here. You can also sort of have task-driven autonomous agents using GPT-4, Pinecone, LangChain for diverse applications. So you can sort of go check out the blog here where he's looking to mention how to do a task-driven agentic architecture here. And basically what he's looking to do is he starts off with the initial input here, looks to have the tasks as execution, with the security agent to make sure, all of your information, all of the data is going in is perfectly secure and sound. It gets the key results. It goes to the task generator, generates a new task within the task list, has the prioritization done. Once it's picked up as the current task, it looks to execute it and then respond back to the user here. So this is another way you can sort of think of it in a more sort of realistic way of how the agentic architecture can kind of look like. So at the core of it, you'll have the memory here, the storage pipeline here. You can sort of have a queue to give it the tasks as they're coming in. If you want to sort of go sequentially and not parallelize your structure here, the user will come in. You can have GPT work as a task creation agent, keep a task queue. You can maybe have GPT again help with prioritization of tasks. And execution agent, again, GPT here to help just, run and execute those tasks end to end, pulling a lot of the context from the memory. You can query the memory again for the context. And just have it work end to end there. Also wanted to sort of chat about here the notable LLM-based agentic architectures and papers that already exist. So you can look at, and these are all sort of in different fields as well. So there's here, you have ChemCrow, which is, a chemistry-based agent that will specialize. It has a chemistry-related database attached to it. So it specializes in things such as, a synthesis of insect repellent and what have you here. Then you can also have specific agents for, say, mental health. You can have agents that are looking to basically work with endowment, preferences, personalities, and to explore the human economic behavior in simulated scenarios. So you have a lot of variety of different agents that are already created here to work for specific fields and specific tasks end to end here. Would really recommend checking these out as well. Also wanted to mention before we start heading into our demo, today's demo, I leveraged SingleStore's free trial to do it, and I would really recommend you also check it out as well. There's a lot of amazing things that it has to offer for you. What I really love is the gallery of code here. With the gallery of code, you have access to all of the sort of prior demos that have been done. So you don't have to, start your notebook out from scratch. You can look through the gallery, look at all of the prior tasks that have been done, run them, edit them around, see how your use case can sort of work with it. You have a database here where you can sort of store a lot of your information there. the development environment, you also have monitoring capabilities here. You have ingestion pipelines. So it really works for, any use case that you can sort of have, and we'll get a better look into it as we get into our demo here. So before we get into our demo, kind of wanted to sort of talk a little bit about what we're going to look at today. So we're going to kind of look at a customer service agent, and this is going to be all console-based, not UI-based here. It's a very simplistic agentic architecture here. It'll have a lot of those planning, decision-making modules that I mentioned, and I've already ran it. It takes quite a while to run it, so I've ran it, and we'll look at the interaction that we sort of had with the agent here. Also wanted to mention that the other option here is, instead of sort of having the other option from what I'll be showing within the demo here, is to also have sort of a RAG pipeline that can feed into the agent as well, to help make a lot of the decisions that the agent is making, especially for our customer service use case, as say documents or customer products may be changing. So having that information would be very beneficial for the agents. That's one option. We've done a lot of the RAG-based, retrieval augmented generation-based demos previously. So I would really recommend you going back and checking those out, as well as checking out the SingleStore's free tier, the gallery for all of the prior code there as well. And just wanted to mention, for the RAG use case, there's this paper that came out, 7 failure points when engineering a retrieval augmented generation system, that you should consider as you're looking to build out your RAG pipeline end to end. So what can happen here, especially early on, is in your database is the key part of the RAG pipeline. You can have missing content. So you need to make sure that your database is kept up to date as frequently as your data is changing here. And then as you come into the query process here, and you say you have a you have a retriever here and you're looking to rank, you can sort of miss the top ranked items here if your ranker is not performing at its best capacity. You can maybe have ranked chunks that are not in the context. The process chunks can be in the wrong format here. They can be incomplete, or you can maybe not have it extracted correctly from your reader. The response can have incorrect specificity to it. So these are the sort of key failure points that this paper recommended. Would recommend you check that out, especially if you're looking to leverage it within your use case there. And with that, we'll head over to the demo here. Okay, so this is the SingleStore environment here. And what we're looking to do here is basically we're going to run our LLM chatbot use case here. So let me start from the beginning. We've just sort of installed all of our libraries here. Okay, so now this is the core meat of the entire sort of our customer support architecture here. So what we're looking to do here is create a customer support agent. And again, this is a more simplistic use case. I would recommend that you try LangChain, maybe add a UI to it, maybe add more tools to it, maybe external API calls to it to be able to create a more sophisticated agent. But you could sort of use this as a stepping stone here. So this is a customer support AI agent that uses a language model to interact with users, providing responses based on the user's queries. So the agent handles perception, decision-making, any action taking to simulate a conversation, basically simulate a conversational support experience here. And at the beginning, you have your constructor, which is looking to just initialize the customer support agent with a specific language model here. Here we've chosen GPT-Neo. It was easier to just sort of have it here, but you can, of course, change out your specific language model per your requirements here. You can even maybe choose one that's more specific for your task. So chemistry, finance, maybe you can have one that's fine-tuned for your task specifically. And basically all we're doing here is we have the model that we're just pulling from the library. We have our tokenizer. We're setting the tokenizer here. We have our chatbot, and we're keeping track of our conversation history as well. Then we have our perceive module here. And the perceive, as we saw earlier in our architecture, basically what it's looking to do is it's going to process the user's input and update the conversation history. Conversation history, which we have within our constructor here. And as its parameters, it's just going to take in the user's input, which is the user's input messages there. And it's going to basically return a string, which has the processed user's input converted to lowercase there. So you have the conversation history, and then the user's input converted there. Then you have the decide module here, and the decide module is just going to generate a response based on the user's input and conversation history. The parameters it's going to have is the user's input, and it's going to just return the generated response from the language model. It'll have the prompt that you sort of have, and it's going to join the conversation history that you have. So it's going to feed in the entire session history as its prompt. This is the input that you have, the specifications, the length of the input, the specifications of the output, the temperature, and what it's going to basically return here. Then you have the act, which is basically going to finalize the response, append it to the conversation history, and return it. So again, very simplistic code structure here to help you sort of kickstart into the agentic architecture here and then just running. And basically it's going to run the interaction loop, sort of allowing you to have that continuous conversation with the user, and the loop will terminate when the user exits or quits. And it's going to start with, hello, how can I assist you today? And it's going to end with goodbye. So just a quick history that I had here was, hello, how can the agent starts with, how can I assist you today? And I typed in that I am having issues with my product. The assistant said, I'm sorry to hear you're having issues with your product. Can you please describe the problem? And I said, I wanted to know the return policy. It looked up the return policy within 30 days. Can you tell me about the warranty? Our products are 1-year warranty. Do you offer gift wrapping? Yes, we offer gift wrapping. Can I exchange it? If your order has been shipped, you can modify it with a support example or a phone number. So you can see this is how it's able to sort of leverage all of the tools that it sort of has within its toolbox to be able to best answer the sort of all of the queries that I had here. Yeah. And with that, I'll hand it back over to you, Yukti, now.
Thank you so much for the amazing demo. So we are now open for questions. Akmal, is there anything that you feel like was like, something that caught your eye? I see that you're typing an answer. So if you would like to take that live.
I think just some requests for the demo code. I think you've posted the link
I've
in the chat,
answered
haven't
that
you?
one. I've
Yeah,
answered that one. So,
yeah, that's it.
yeah.
And since we're almost at the end anyway, yes. So if you've signed up, you'll get a follow-up email with a link to the recording.
Yeah.
Some people requesting Vanita's slides, I think. That is for Vanija. So I'm sure
I
we
can
can
have
arrange
them
something,
too.
but
I can share them as well.
yeah, I think those were the key things. The rest, I think, just focusing on agents really and what they are and how they can be used and how they can be applied, and various analogies that you could use to explain them, and and so on. So I think those are the main things.
Yeah, definitely. So There's no simple answer to how to describe agents. The way I think about it is any sort of workflow that you have, say the customer service workflow, where maybe you have to call in to get your answer solved. Maybe it's your internet connection, your bank, whoever you have to call. That can just be translated to an agent end to end. So, the call, it goes into a voice, an ASR, gets translated to text, goes through an LLM. The LLM understands the user's question, then it can use all of the different tools that it has. So maybe there's some billing problem with your bank. That's what the user is looking to do, or it's looking to find out the balance. The user is looking to try to find out the balance that they have. Then it can leverage the APIs to query into the user's bank and then get that information back to them. So any of these flows that you have that can sort of be automated end to end, anywhere where you sort of need like maybe customer service reps. That's sort of where I'm thinking, AI agents can sort of be plugged in. But as we saw in our examples, the futuristic view of them is that they live in society as physical beings and they sort of help us out with our everyday tasks, like just getting us an umbrella depending on the weather, too.
Sounds good. So we actually have a lot of other questions. Akmal, I feel like you can take this question somewhere. I had a question regarding, I can't find it because we have a lot of questions flowing in.
Yeah.
So we have a question from Karthik. They say that single store trial can be used for building what kind of project? So is there something that you would like to recommend? Or maybe Vinija, you can also jump in and just, you know, you can let us know if like you have any ideas.
Yeah, I'll say some words quickly and then hand over to Venetia because she's independent. Okay, so she doesn't work for single stores. So her viewpoint is a different one, perhaps from mine. All I would say is that I mean I've been with the company about 3.5 years now, and so initially I used to use the standard tier because that was the only option that was available. With the free shared tier that's now available, I try and do as much of that on there as I can. Great for small scale projects, POCs, limited quantities of data, just something to get up and running quickly. Because the thing is that for the sign up page that you've provided, Yuxi, people just literally, I think you mentioned it's like 30 seconds a minute. There is, you're prompted, there's one or two questions you need to answer. And then as you log into the portal, I mean, already the resources are created for you. So you get, a workspace and you get a database. And yes, there are some limitations around that. I mean, you're not going to build an enterprise application in that environment, but just to try it out, get your hands on, get some experience, and that's a great kind of starter place. And I think that we've been asked sometimes, is there something that Single Store provides that's beyond just the free sort of shared tier, but not quite having to pay lots of money for enterprise sort of services? And there is something that's kind of coming in the middle. So you pay a few dollars each month, you get more, in terms of capacity, storage, and those kind of things. And that's, I guess, really for people who perhaps are not regular users, but might want to be able to do projects from time to time that are larger in scale. I try and use the free shared tier as much as possible now, simply because it's more convenient. Something's just running all the time. I don't have to worry about burning through credits. But that's my experience, and I think I'll hand over to Venetia. So she'll provide a kind of an independent viewpoint on that.
Yeah, so kind of to add on what Akmal said there, every single one of the webinars I've done, I've actually leveraged the free tier. So it is very good for the POC and the sort of quick demo to sort of create here and showcase the concept. Also, it's very convenient because you do have the database, vector database, any of the sort of things you need all in one place. So that makes it very easy to sort of navigate. You have your notebook, you can store data, you can visualize it all in one place. It's been easy to debug. It's been easy to get settled into the environment. So yeah, I would definitely recommend it for as starting off. And like I mentioned, I really love the gallery of code there to help start off any project that you have there.
We actually have so many questions. So we have a question from Rick Austin. They say, what's the highest level of liability responsibility? Uh, has a bot been given that you have seen? that is change of address, change of bank info, etc.
Yeah, so just wanted to clarify that a specific bot or an agent won't be sort of given the entire responsibility there. So what it's only going to do is it's going to understand the flow to go through. So um, if the user wants to understand their balance, it's going to sort of click into that flow, and you still have to go through any authentication, API calls, users information. All of those credentials still has to be gone through in a traditional software engineering pipeline. And then the response that it gets is going to be fed back into the agent, then back to the user. So it's not like the agent is sort of working as the trigger point here, but it's not actually going in, checking your bank account and doing that's still a software engineering pipeline. The agent's sort of helping work as a orchestrator here, basically.
Good. So we actually I do see certain comments about future webinar topics. So you know what? If you have any suggestions, feel free to connect with me on LinkedIn, and you can just always drop a message. And I can plan something out, and maybe I can work with Akmal, maybe I can work with Vinija. So with Vinija, we can work with Aman as well. So we'll figure something out. We have okay. So there's one question. They want to see a session on real-time text detection using YOLO. So it's up to the panel. Like, is it feasible?
I think we had who was that guy from Georgia Tech? Do you remember his name, Yuksi?
Oh, Ayush
Yes,
Pai, right?
Ayush Pai. He
Yeah.
used YOLO and he used it for basketball. And I think that was
Hmm.
the first webinar actually he did. So he did a really cool one. And he's just using his phone to do the
I know.
video. You know, people are
Yeah.
asking what's his setup. And that was actually very cool. So I think we can dig up his repo, find out what it is. But I'm sure
Hmm.
that you should, with a little bit of effort, you could adapt it for other use cases as well. But that was an excellent sort of demonstration of using that technology for this sort of particular problem.
Hmm. We actually, I think you are the author for getting started with single store, right?
Yes, that's right. The notebook that's in gallery that's labeled as getting started. Essentially, it does a little bit of sort of SQL, sort of some simple operations, average, some min max, and then it does a little bit of other things as well. So it's a bit of geospatial. So you've got like a bunch of cities across Canada, and then you've got people that are distributed. They've put some orders in. And then there's some JSON information that's added, for example, delivery information. And then you're actually trying to find the location of people as well, running these kind of geospatial operations. And then I think there's a little bit of time series as well. So what I tried to do, and Madhukar asked me to do this, is just a little bit of everything, just to give people a flavor. I think the only thing missing in that notebook is key value. So that's
Yeah, someone
something I
has
may
put
add at
a
some point.
comment. Yeah, I'm so
Yeah.
sorry, but someone has
Yeah.
put a comment that the order table is missing dimension column. So is that something that you can tell them that where it is located, or maybe is this something that you would like to take a look at?
Yes, anything. I mean, remember these notebooks are just templates. If you think of it that way, you are very welcome to extend them and adapt them and change them in whatever way you wish. If you have real data that you want to try out, by all means do that. There's some cool features that we provide now. Something called Stage, for example. It's a great way to upload data into this environment. So if you've got, say, a CSV file and you want to get that into SingleStore quickly, rather than having to use, say, a MySQL client CLI from the terminal. I mean, I use that. I like it, but there's an easier way now. You just upload it into Stage, and then straight away from your Python, IPython notebook, you can just access that and say, read the data into a pandas data frame. Now you can do something with it very, very quickly. Very simple operations. There's, as Vanisha mentioned, there's lots of different notebooks for many different applications. If you want to read from an S3 bucket, there's a notebook for that. If you want to work with SingleStore Kai, which is the MongoDB compatibility, there are notebooks for that. Yeah, and by all means, feel free to adapt them to your needs and change them as you wish. Any specific issues, if stuff is broken, just drop us an email and let us know, okay? And we'll fix them.
Right. So it seems like we are almost we are out of time now, so we need to wrap up. Is there any question that Akmal you feel like, or Vinija, maybe I don't know if you can see the questions. So, oh, I'm so sorry about that. We need to fix that actually. Akmal, is there any question that you would like that Vinija addresses, or is there something that you would like to address?
No, I think I've done my best to answer as many of the questions
Yeah,
as I
same.
could. My
Yeah.
poor fingers are kind of bleeding now, so my typing speed is not great, but I've done my best. Uh, but yeah, so again, lots of people just asking about the recording. Yeah, I mean, if you've signed up, you will get a follow-up email. And the fact that you're asking the question means you have signed up. Okay, it's a kind of a tautology, all right? It's so.
I see one question, like this
Yeah,
will just take 30 seconds and then we'll wrap up. One question
yeah.
about SingleStore. Can SingleStore run in as in an edge device embedded system, like in brackets? If so, what is the smallest ballpark footprint it can run on, like CPU and memory?
That's a great question. No, it is really designed as an enterprise product. So we don't have an embedded option that I'm aware of, and I've been here 3.5 years. So it does require some resources. The cloud-based environment obviously has some configurations already preset for you. If you want to install it yourself, I wrote an article a couple of years ago how you could install it yourself in a virtual machine. And I do that sometimes because sometimes in the cloud-based environment, unless you're an administrator and have godlike privileges, for example, there's things that you cannot change because they are preset, which is good. Whereas if you install it yourself, you can control everything within that environment. And sometimes I like to do that. So I install it in a virtual machine, but the footprint, I mean, you do require based on how large a cluster you want to install. I think a minimum you're talking about 8 GB, and that in no way. I mean, devices these days do, and handheld devices. My phone, for example, has got quite a bit of memory and quite a bit of storage on there. But we don't have a single store in a version that would run on there at the moment.
Sounds good. So I think we need to drop off because Vinija might have to, I know it's a Monday. So thank you so much everyone for attending. And you are welcome to participate in the raffle. We will with the entries are still on. So the link is in the chat and you're welcome to participate in the session. And we will enter you automatically even if you still have account with us. We will be able to see if you have entered during this particular time, so I have access to that data. The link to Vinija's repo is in the chat, and you're welcome to participate in the next webinars that we are having. So tomorrow we are presenting building enterprise grade RAG with AWS agents and singles. So it's very similar to this webinar. I think this is like they are also using agents. So this was like a coincidence actually. And on 24th, that's also a partner webinar, building secure scalable data access APIs with Hasura and SingleStore. So if any of these topics are interesting to you, feel free to RSVP right now and I will see you there. So thanks again for attending. Like your time is very valuable to us. And if you have any questions, feedback, drop in a message to me or our team at singlestore.com or anyone over here. So thanks, Vinija, for delivering this amazing session. Thanks, Akmal. I know it's a holiday. I didn't know about it. Thank you so
You're
much.
working on your holiday as well.
I didn't know that. So,
You need
yeah,
to
that's,
check your calendar. Ask for a
I
day
don't
in
see
lieu.
it. I need to speak to the HR.
Yeah, yeah, yeah.
Okay. So, all right. I'll conclude this session now. Thanks, everyone, for
Okay.
attending. Take care, everyone.
Thank
Bye-bye.
you.
Bye
Bye.
bye.